All right, welcome back. So now let's get into the notes section for solving rational equations. And thankfully, there's really not much of a notes. The only notes we have is the extraneous solutions. And those, again, are just going to be the solutions that solve a simplified equation, but not the original equation. So what I have here is two examples. And, the process that we're going to follow once we get into solving equations is, kind of what I showed you is getting rid of these fractions by multiplying by the LCD. So here we have these equations, all right? And they're very, very similar to each other. But the process that we'd use to solve them would be the same. We'd multiply by the LCD, which in this case, actually in both cases, is going to be x minus 3. So when I multiply everything times x minus 3, and I mean everything times x minus 3, I'm going to get an equation x times x minus 3. Here the x minus 3s would divide out, so I'd be adding a 4x. And then here I'd get the x minus 3s go ahead, divide out again, and you get a 12. You could go ahead and distribute here, x squared minus 3x plus 4x equals 12. In this case, I notice that I'm going to be dealing with, in this case, I recognize that I'm going to be dealing with a quadratic equation. Now, again, a quadratic equation has two solutions, right? Or at least possibly the maximum number is going to be two real solutions. So I can just go ahead and simplify this, subtract the 12x on both sides. You get an x squared. Let's see, that's going to be plus x minus 12 equals 0. Now, again, the solving technique to solve an equation typically is going to be factoring or quadratic formula. Thankfully, this looks like it's factorable. So x plus 4 times x minus 3 equals 0. And then you can use the zero product property. So x plus 4 equals 0 and x minus 3 equals 0. So therefore, x equals negative 4 and x equals 3. Now, again, it's very important for you to understand that those are the solutions to this equation, right? If I just if I just gave you this problem, like this equation, I said solve, you would know, okay, well, the maximum number of real solutions is going to be 2. Solve, here's my 2 real solutions. But again, that wasn't the original question, right? The original problem was solve this equation. And what happens is when you plug in negative 4 in for x and you plug in 3 in for x, you're going to get different results, because when you plug 3 in for x, you're going to get 0 in the denominator. So that's why x equals 3 is what we call extraneous. Okay, it satisfies this equation, right? If you plugged in 3 and negative 4 in for x, you would both get negative, you get 12 is equal to 12. But when you plug it back into the original equation, 3 does not work. So it only satisfies a simplified equation, not the original. So let's take a look at another example of how this would play out. So in this case, again, we'd multiply by x minus 3. All right, when we multiply by x minus 3 here, we get a 3 times x minus 3 plus a 2 times x minus 3 equals a 2 times x minus 3. Oops, I'm sorry. Those are going to divide out. Equals 2. All right, and then we could apply a little distributive property here, 3x minus 9. And then plus 2 equals 2. Therefore, 3x minus 7 is equal to 2. Add a 7. 3x is going to equal to 9. Divide by 3, x equals 3. And again, that makes sense, right? Because if you look at this, again, the simplified equation, you have a linear equation. And you could solve a linear equation, right? And you're going to get one solution. Makes sense. However, when you plug 3 back into the original equation, again, you see that 3 is going to make the denominator equal to 0. It's not going to satisfy the equation, right? So it satisfies a simplified version of the equation. It does not satisfy the original equation. So this is extraneous solution. And since this is the only solution, we could say that this equation has no solutions. And that is how we find extraneous solutions as well as how we define them. So now let's go ahead and work into practicing the process videos, which will be basically practicing more of these examples, but then also keeping an eye out for your extraneous solutions. I'll see you guys there.